you could imagine maybe I gathered all the information for all, 60 of you guys, all right? Now I could make this dot plot, and if there were 60 students, how many dots would I have in my dot plot? 60. I would have 60 dots, 1 dot for each student, okay? Now, in making that, some people might complain, there's too many dots and it hurts my eyes, okay? And that would be a valid complaint, okay? Because all of these tools that we use, these are meant to serve us, right? Sometimes people show us pictures and charts, and there's just too much going on, okay? And in those cases, it's not so useful. So we might, instead of, so you can imagine, let's say I made a dot plot, and there was just a whole bunch of dots. Something like this, okay? Well, this can be turned into, so rather than having the dots, I can make the bars instead, and it would look something like this. Okay, these two graphs have the same information, right? And well, it doesn't seem like maybe you can read this just as easily as you can this, okay? But you can imagine maybe there was 1,000 dots or something, and it might be a problem, okay? It might be a problem. So this is known as a histogram. Okay. And here we use bars to represent basically in the place of the dots, okay? We use bars in place of the dots. All right, so just quick understanding check. Do we use histograms for numeric data, categorical data, or both, or what? Okay. This is for numeric data only. Okay, histograms are for numeric data. What about dot plots? Numeric data. So both of these things are only for numeric data because we've got, basically we have a number line and it tells us we're answering how many years or how much is your age, how old are you, and so this stuff is used for numeric data. Okay. Yes.
What if there's segmented bar charts?
I'm sorry?
If there's segmented bar charts.
Segmented bar charts? Okay. We'll talk about bar charts. I don't know if we'll talk about segmented bar charts, but we'll talk about bar charts. And bar charts are for categorical data. So I don't know, maybe you got that from another stats class, and we'll talk about that in a moment. But here, this is a histogram, and it's not a bar chart. Okay, it's a histogram. All right, somewhere along here, along the base of the histogram, there's numbers. Okay, we've got numbers all along here. Okay, the dot plot starts off with a number line, and the histogram also starts off with a number line, except we're putting bars on top rather than dots. Okay. The book also talks about something called a stem plot, but we won't worry too much about that. Okay. When we are describing data sets, okay? So here I've got 5 numbers. How would you just describe something like this? You got Here I've got 5 students and their ages. Can you give me a description of their ages?
Mostly around their 20s.
Okay, so we'd say something like, most of the ages are something in their early 20s, and we've got a student who's 30 and things like that, okay? Well, the same, we're trying to say, how can we describe this set of numbers without having to list off all of the numbers, right? You're on the phone, and someone says, oh, can you just describe what the ages are like in your class? Okay, and you just imagine we've got 60 students, and this is what the ages look like, okay? Well, there's a few things that we want to talk about, okay? One is the center of our distribution. Another thing is our spread, and we want to talk about the shape, all right? And we'll talk about the center and spread later on, okay? These are, that'll come next week, okay? But our shape, we basically want to describe, is it symmetric? Or skewed? Okay, and also, is it unimodal or multimodal? Unimodal, I should say bimodal or multimodal. Okay, symmetric or skewed. So if I took this, here's my histogram. I could summarize it just kind of with this curve that looks like this. And this kind of captures the essence of this, right? So this might be a little bit of a leap. But I could have different shapes. All right, and so just remember, underlying this, so I've got these shapes here, all right? This one is symmetric. This is skewed left. And this one is skewed right. And if we had something that looks like this is known as uniform. All right, and if you're going to have trouble remembering skewed left versus skewed right, just imagine if I had to, if I cut this out of the board and used it as a weapon, all right, which side would I use to skewer you or stab you? I would use the left side. Okay, that's the pointy side. That would be the side I would use. All right. But I'm not promoting violence of any kind, okay? And this one is symmetric, okay? The idea is that side, you can put a mirror down the middle and both sides look the same. What does it mean to be skewed right? Yeah?
Most of the sample is on the left side of the number line?
Yeah, okay, so skewed right means, the bulk of our data, okay, most of the people, so this is our ages, okay, maybe this one down here is 19 and this up here is like 25 or something. It says, most of our people are in between this age range, okay? But I've got some people who extend beyond to the right, being higher than the bulk, okay? But I don't have anyone going this way. I don't have anyone less than the rest, okay? So, this means, so skewed right, most people are in a certain range. A certain range. A few people are much higher. But no one is much lower than everyone else, or no one is much lower than the bulk.
So that'll be a skewed right.
Hang on. The bulk. bulk of the group. And that would be skewed right. Okay. Skewed left would be just kind of the opposite story. Most people are in this kind of upper range here. We've got some people who are much lower, but no one is that much higher. Okay, does that make sense? Symmetric, most people are kind of in the middle. I've got some people who are much higher, and I've got some people who are much lower. I've got just about as many people high as I do down low. Uniform, what is this? Everyone, at least in this range, shows up just about as equally as often as everyone else. Okay? So that is one aspect of the shape, symmetric or skewed. The other aspect is unimodal, bimodal, or multimodal. Okay, unimodal means one peak. Right? It means so actually all of these are unimodal. There's basically one range or one zone where most people exist, okay? And that's it. So this is, whatever, that's unimodal. Bimodal, two peaks. Okay, so maybe it looks like this. A lot of people exist in this range, a lot of people exist in this range, okay? And then bimodal could also be something like this. A lot of people exist over here, and some people exist over here, but there's two different peaks. Yeah.
So, what would the uniform be?
Uniform, yeah, we just call it uniform. We don't really say unimodal or bimodal there.
Okay.
We just say uniform there. Okay. So unimodal, this would be something like if we just look at one gender. So if we just look at men, and we say, what's the how tall is a man? Okay, most men are somewhere around between 5'8" and 6 feet tall. Okay, most men are kind of in this middle zone between 5'8" and 6 feet. Some men are taller, and there's some men who are really tall, and then some men are shorter, and some men who are really short. But most are kind of in this middle zone. All right. When we're talking about heights of everyone together, this could represent, heights for men and women. Okay, so we've got a peak kind of where the average man is generally taller than the average woman. So we've got some. We're going to have a peak over here and a peak over here for the women as well. Okay, so we've got bimodal, and then anything more than that, sometimes you have this. Generally, it's a 1, 2, or many. So once you go much higher than that, then we just say multimodal. The book also talks about, the center and the spread, just very briefly in kind of this big picture concept, right? Where we looked at the dot plot of the, ages in one stats class versus the ages in the high school stats class, and we said the top group had more spread than the bottom group. All right, just hang in there for a few more minutes. Okay, so this has all been for numeric data. So these terms, unimodal, bimodal, multimodal, these all only apply to numeric data. So let's.
Uniform as well.
Uniform also only applies to numeric data. All of these, everything basically that I've talked about so far in chapter 2 applies only to numeric data. All right? So make a big break and say, this is now categorical data, okay? All right, so what have we looked at that was categorical data? What was a categorical variable? Gender, okay? And race, things like that, okay? So maybe we looked at our students and we had, you know, male, male, female, or something like that, okay? And how do we summarize this? What do we call that? Yeah, frequency table. Okay, and we write male versus female. And what do I put? I put the count, and I've got 3 males, 2 females. And then maybe we want to do proportions, okay? 0.6 and 0.4, 60%, 40%. All right? So we can graph this also. This is where we create a bar chart. And for here, I would put a bar chart for males. And then, I'm sorry, a bar for male and a bar for female. And some of you might ask, this looks a lot like the histogram, okay? Especially if I had a whole bunch of categories or something like that. Bar chart is not a histogram. Why? The ordering of the bars are arbitrary, okay? Equally valid, I could make a bar chart that looks like this. And put female over here and male over here, okay? This bar chart tells me the exact same information, and this is equally valid. I cannot do that with the histogram. Why not?
Is this on a number line?
Because it's on a number line. I don't have the option to say 6 comes after 9, okay? I can't do that. The numbers go 1, 2, 3, 4, 5, 6. That is set. And the bars on the histogram, or the dots on the dot plot, they go where the numbers are, and it's on a number line. I can't rearrange that. But here, there's no reason why male should go on the left and female should go on the right, or female on the left or male on the right. The ordering is arbitrary, okay? If we did a listing of races, okay? The ordering, again, is arbitrary. There's no reason why one ordering is more or less correct than another, okay? And that's the key feature of a bar chart, okay, is that you can put the bars in different order and the bar chart is exactly valid. Kind of to illustrate this, we put spaces in between the bars, but that's maybe less of a critical point, okay? But the order of the bars don't matter. Okay, so imagine, so this is one class where I had 3 males and 2 females, and that was the bar chart, okay? Okay, so let's just imagine I went to another classroom, another class, and I said male versus female. Okay, let's say there was 1 male and 9 females. What would that bar chart look like? It would look something like this, right? Okay, and I should probably put one. Put a number scale on the left-hand side. Okay, so this is one bar chart. One male, 9 females, and then the other one I had 3 males and 2 females. Which class has more variation when it comes to gender than the other?
The one on the right?
This one, right? So this has more variation, and this has less variation, okay? This is because when you look around, almost all of your classmates are female, okay? Over here, when you look around, some are male, some are female. You've got more variation here in terms of who your classmates are than over here. And so you've got basically one category that's completely dominant. You're going to have less variation, okay? So, is there more, maybe, what do I say, ethnic variation in Los Angeles or in, let's say, maybe, Shanghai, China, okay? Well, in Los Angeles, we've got a lot of different ethnicities, a lot of different races, okay? And if we created a bar chart for the different races, it would look something like this, okay? There'd be a whole bunch of different racial groups, and it would look like this, okay? If we go to Shanghai, China, okay, it's going to be like almost everyone in Shanghai is going to be Chinese, and then sure you will have a few other racial groups, but very few. And so this is Los Angeles. Something like that. Okay, so this one has more variation, less variation, and you see that also illustrated in the book. Okay, that's it for today. You guys have homework 1, and that's due next week. We'll see you guys next week.